As always, you want to read the question first and read carefully. I'm going to give you a few seconds to go ahead and do that. I'll wait. Okay, did you notice anything interesting about the wording of the question? Which of the statements below does not match the motion map? I noticed that it says, which of the statements below does not match the motion map? Clear example of why you always need to read carefully. Now, before we look at any of the answer choices, I want to go ahead and say everything I can about this motion map. So I'm going to take a closer look. First of all, what exactly are we looking at here? I would call it motion to the left. How do I know that? Well, time only moves in one direction, and since 0 begins here and 5 is way down here, the car must be starting at 0 seconds here and moving 1, 2, 3, 4, 5 seconds. But to learn more about the motion, let's take it 1 second at a time. You can do this same method on your page using a pencil and a straight edge. Okay, at 0 seconds, let's use the front of the car to mark the position of the car. So at 0 seconds, the car is at 6.5 meters. And after 1 second, the car has traveled to this position. So what is its change in position? Well, if each space is worth a quarter or 1/4 of a meter, then 1, 2, 3, 4 spaces makes 1 meter. So let's count how many spaces we've got from 0 seconds here to 1 second there. One more time. 1, 2, 3, 4. That makes 1 meter and 1/4. So we have 1.25 meters. So the car's change in position is 1.25 meters to the left, which in this case is the negative direction. Now if we look at the time interval from 1 to 2 seconds, we can see that the displacement is once again 1, 2, 3, 4, that's 1 meter and 1.25 meters to the left once again. Then we go from 2 to 3 meters. Sure enough, same displacement. 3 to 4 meters, looking good. And 4 to 5 meters, still a constant velocity there. And so it looks like the displacement is always negative 1.25 meters. And since our time interval between each of these dots was 1 second, then our velocity is negative 1.25 meters per second. Okay, now we're ready to take a look at those answer choices. The first one says the object travels 1 meter every second. Well, since we already figured out the displacement was 1.25 meters in 1 second, I think that might be our option right there. But just to make sure, we better go through all the answer choices. Okay, the second one. The velocity of the object is negative 1.25 meters per second. That agrees with what we determined it should be. The object had a displacement of negative 2.5 meters in the time interval from 1 second to 3 seconds. We didn't verify that one because we only did 1 second at a time. But here's what we can do. Let's go from 1 second here to 3 seconds and count the spaces. We've got 1, 2, 3, 4. That's 1 meter. 1, 2, 3, 4. 2 meters. And 0.25, 0.5. Sure enough, 2.5 meters in the negative direction from 1 second to 3 seconds. So that one's also true. Position of the object at a time of 2 seconds was 4 meters. Well, let's go to 2 seconds. That's here. And sure enough, 4 meters. Make sure you're looking at the right units. The seconds are the dots. The meters is the ruler. And it can't be none of the above because we decided that it didn't move 1 meter every second. So that first option, that's our choice.